Let's be real for a second. Machine learning isn't just about writing a bunch of code in a notebook. It's really about building an entire intelligence system, a factory, if you will, that consistently, reliably cranks out valuable insights. So today, we're going to walk through the blueprint for that exact factory, all built on Azure.
You know, when you think about AI, it can feel a little bit like magic, right? A model makes a prediction and it just works. But how do we actually get there? I mean, how do we build these incredible systems reliably, over and over again, and at a massive scale?
Well, the answer isn't magic at all. It's a factory, a really sophisticated, automated process for producing intelligence. And today, we're going to walk through the complete blueprint for building this factory, all using the principles of Azure MLOps.
Okay, so every great factory starts with a solid plan. You absolutely have to know what you're building and, more importantly, why you're building it. For our intelligent factory, that means we first have to define the product and the problem it's going to solve. The product our factory is going to build is what's called an anomaly detection system. You can think of it like a digital detective, one that's been trained to spot really unusual patterns in a giant sea of data. And for our example today, its mission is super clear: identify financial transactions that might be fraudulent.
And why does this even matter? Well, take a look at this number. Financial fraud can cost the economy tens of billions of dollars every single year. This number, this is our why. It's the reason our factory has to be both incredibly efficient and ridiculously accurate. The stakes are huge.
So, with our product defined, we're heading to the first part of our factory, the ML lab. This is basically our research and development wing. It's the place where data scientists get to experiment, test out their wild ideas, and try to create the core intelligence for our product.
Now, a modern ML lab isn't some chaotic mess. It's more like a pristine scientific laboratory. And in Azure, every single experiment is meticulously documented. We're tracking the exact version of the data, the code, the model's performance, even these things called hyperparameters, which are like the little tuning knobs for the algorithm. All this rigor means our work is repeatable and totally auditable.
And that's the whole point of this R&D phase, right? We are iterating, we're testing, we're refining, all to find that one perfect formula, the single best recipe that gives us the highest performing model, way before we even think about mass production.
Okay, once we have our winning recipe from the lab, we can't just have a data scientist manually cooking it up every single time a new model is needed. No way. We need to automate this. We need an assembly line. This is where we take all that amazing research and turn it into a repeatable MLOps pipeline.
And this is the heart of our assembly line right here, a series of automated steps. It pulls in the latest data, it trains the model using our winning recipe, it evaluates how well it performed, and if it passes the tests, it registers that new model as an official, production-ready asset.
You know, this pipeline is such a crucial point. It's where the world of DevOps, that whole practice of automating software development, officially shakes hands with MLOps. We're taking that same engineering discipline and applying it directly to the AI development process. It's a game changer.
So, our factory has just produced a high-quality, perfectly versioned model. Now, it's time to ship it. But getting the model out into the real world so it can actually make predictions, well, that requires a pretty critical architectural decision. On Azure, we have a key choice to make. We can use Azure Kubernetes Service, or AKS. Think of this like owning and operating your own powerful, highly customizable shipping fleet. It gives you maximum control for really complex, high-traffic situations, but it also requires more hands-on management. Or we can use managed endpoints. Here, Azure basically acts as our logistics partner, handling all the complicated infrastructure for us. It's way simpler, it's faster, and honestly, it's perfect for most common deployment needs. The right choice just depends on your project's scale and complexity.
But hold on. Our job as the factory manager is not over once the product ships. Not even close. We're now entering what might be the most critical phase of all: live quality control. We have to constantly monitor how our model is performing out there in the real world.
Because this is what always happens. This chart shows a classic case of what we call model drift. At launch, our anomaly detection model might be amazing, like 98% accurate. But 6 months later, as real-world fraud patterns change, its accuracy could plummet down to 85%. The world just doesn't stand still.
And that's the whole idea, isn't it? Monitoring is what detects this drop in performance. It acts like a big alarm bell for the factory, signaling that our current model is getting stale. It tells us it's time to send it back to the assembly line for a retrain with fresh, new data.
So let's bring this all together. As the architect of this intelligent factory, what does your day-to-day life cycle really look like? Well, we can actually boil it all down to a simple but really powerful checklist.
Here it is, the whole shebang. First, you experiment in the lab to find the best possible model. Then, you automate its creation with a pipeline. You register the output as an official versioned model. You deploy it to the best target for your needs. You monitor its performance relentlessly. And finally, the moment you detect drift, you trigger the pipeline all over again to retrain and create a new, better version. It's this continuous, beautiful loop of improvement.
This MLOps lifecycle, this is the blueprint for building intelligent systems that can actually scale. It transforms machine learning from a kind of one-off artisanal craft into a repeatable industrial process. So, now that you have the keys to the factory, what intelligent product are you going to build next?